Pennsylvania. For question 1, it reads, consider the $50,000 excess cash. Assume that Gary invests the funds. For part A, what is the CD's value at maturity, or the future value, if it pays a 10% annual interest? So what we did is we plugged this directly into Excel using the future value, the FP formula. You see here, you just simply plug in rate, make sure you have the comma, then N per for the number of periods, then make sure there's 2 commas, and then have a negative present value. Our answer was, for future value was $55,000. For part B, it reads, what will its future value be if the CD pays 5% interest? And also if it pays 15% interest. So again, we plug this in Excel using the future value. As you can see, for the first part of part B, for 5%, we got $52,500. And for the second part, we got $57,500. Question 2. So then it asks us to rework the parts A through B of question 1, assuming that each CD has a 5-year maturity. So for the number of periods, instead of having 1, we change that to 5. Future value formula. For that, for part A, we got $80,525.50. We then did the same thing that we did in question 1, and we worked it again using the number 5% interest rate, $3,814.08. 10% interest rate, $100,500. For part 3, we switched and we use the present value. The question goal of having $200,000 available in 5 years to buy a new patient billing system. Reads, what amount must be invested today in a CD? So for this, we know we want our future value to be $200,000. And so we use the function in Excel and the future value, the rate, and the number of periods. It reads, what annual interest rate is needed to produce $200,000 after 5 years if only $100,000 is invested? Again, we're going to use the rate, a formula in Excel. We received 14.87%.
All right, now for question number 4. It says, now consider a second alternative for accumulating funds to buy the new billing system. In lieu of a lump sum investment, assume that 5 annual payments of $32,000 are made at the end of each year. So part A asked, what type of annuity is this? And the answer is, it is an ordinary annuity. This is defined as an annuity that has payment that occurs at the end of each period. So for part B of question 4, the question was, what is the present value of this annuity if the opportunity cost is 10% annually? So for this part, we just use the present value of annuity function, the present value function in Excel, by plugging in the rate, the number of periods, and the negative payment amount, which gave us $121,305.18. And then the second part of part B asked, what is the present value of this annuity if the opportunity cost is 10% compounded semi-annually? So for this problem, we had to use the EAR, which is the effective annual rate, instead of the given rate in the problem. And this is because the EAR will, it says the interest rate that under annual compounding produces the same future value as was produced by more frequent compounding. That's the definition from the book. And so when you use the EAR instead of the given rate for semi-annual compounding, but used under the present value function in Excel, for part B, you get $120,534.40. So question 4, part C, it says, what is the future value of this annuity if the payments are invested in an account that pays 10% annually? And so for this one, you just use the same function. So you plug that into the future value of Excel, and it gives you $195,363.20. And then the second part of part C asks the same thing, but if it were 10% compounded semi-annually. And for this one as well, you have to use the EAR because you're changing it to compounding twice in a year. And so the future value function is $196,337.83 is your answer. So for question 4, for part D, the question asks what annual interest rate is required to accumulate the $200,000 needed to make the purchase, assuming a $32,000 annual payment. So again, in Excel, this time we use the rate function and numbers in, and it gave us a rate of 11.18%. And then for part D, the last part of question 4, it says what size annual payments is needed to accumulate $200,000 under annual compounding at a 10% interest rate. So once again, we used Excel and we used the payment function in Excel and plugged those numbers in, and it gave us $32,759.50.
Okay, for question 6, it says, now consider the uneven cash flow streams stemming from the lease agreement given in the case. And it says, use the net present value function in Excel. So for part A, it says, what is the present or year 0 value of the annual lease cash flows if the opportunity cost rate is 10% annually? So you just, in Excel, you type in the equal sign and then NPV, and it'll tell you what to put in. And then the answer you should get for that is $47,328.61. And then for part C of question 6, it says, does the office renovation and subsequent lease agreement appear to be a good investment for the company? So if we plug in all of that to get the net present value, it comes out as a positive $7,328.61. So we would say that yes, the renovation returns a positive net present value, so it would be a good investment. And then question 7 says, now assume it is 5 years later and the company is unable to accumulate the $200,000 needed to purchase the software. Instead, it is forced to borrow the $200,000. The loan calls for repayment in equal annual installments over a 5-year period, with the first payment due at the end of 1 year. Assuming that the company can borrow the funds at a 10% rate, what amount of interest and principal will be repaid at the end of each year of the loan? So what we did was we created an amortization table in Excel, and it calculates it for you. So over the 5 years, you just plug in the payment amount that you'll be doing every year. So the loan amount, $200,000, and the interest rate at 10%, and the number of periods is 5. And it tells you exactly what your interest will be and what your principal will be each year. I wanted to do it longhand, this is the equation that you would use. And as long as you are waiting to round until the very end, like as late as possible, then it should come out to 0, but sometimes rounding gets off, so we got it to come out to 0.01 cents. Thanks, guys.